This video is going to highlight some of the differences between case control studies and cohort studies. They both have some unique benefits, and basically I'm just going to talk about how the two different study designs would approach basically the disease experience in the same population. So it's a thing people say in epidemiology textbooks that all case controls are theoretically nested in a cohort study. And what they basically mean by that is that you could conceptualize the cohort that gave rise to a case control and basically look at it as the disease negative group not being completely enumerated in the case control study, where it's basically using the data from a cohort study and taking a random sample of those that are disease negative. But that'll become clear in a second. So basically with case controls, it's retrospective in nature, where when the study process is happening, everyone is already had their exposure and disease or lack of disease occur. Basically, follow-up is over. And you use all of the disease positive people and a sample of the disease negative people, because case controls focus on rare disease, and the number of disease positive people are usually much smaller than the number of disease negative people. So you kind of have your pick of disease negative people and you take a sample of them. You prioritize getting disease positive people into the study. You would rarely exclude people that are disease positive unless there's some exclusion criteria that they have. With a cohort study, you sample disease negative people, so you figure out the disease status of people in your sample and exclude those that already have it, because you're interested in witnessing people go from disease negative to disease positive. Basically, you want incident cases. So some people who were initially excluded, so you took even though you had even though you excluded everyone who is disease positive, you still took a sample of the population, and some of those people who got excluded, who weren't part of that sample, might have gone on to get the disease, and they are not involved in the study, basically. And you basically are prioritizing getting disease negative people into the study in the hopes that enough people will develop the disease over time that you'll have enough statistical power to detect the effect. It's easier to see this with visuals, but that was just kind of some groundwork I wanted to lay first. So some view, like I said before, a case control as a cohort study where the disease negative individuals are missing at random. That's an interesting way to look at it, where I guess the missing at random part is accounting for the fact that we want our disease negative people to have a representative exposure distribution. We don't want them to be excluded for reasons that are related to their exposure status, because then you get a selection bias situation. Basically, this is a neat way to look at what it's kind of theoretical. That's not literally what it is, but it's conceptually similar to what it is. And where case controls get their efficiency is that disease positive people, especially with a rare disease, are usually much more information dense. I'm going to do a video soon on case controls that'll kind of touch on why that is, where if you have 10 cases for every 10 controls for every case, having more controls per case after that is not going to increase efficiency, because at that point the bottleneck, the limiting reagent there, is disease positive people. Usually, disease positive people they're more information dense, which is a kind of nebulous concept, but just kind of take that at face value, I guess. So if this is the disease experience of the population, so in 2017, no one was disease positive, but we had all of these people who are the people who are colored black are exposure negative and disease negative. The people with the blue outline are exposure positive, and over time people developed the disease after 2020, and some of those people were exposure negative, some were exposure positive. And basically that generates a table like this, where we have our distribution of exposure positive and negative and disease positive and negative. So if a cohort study and a case control study was to analyze this population, they would basically get information at different times and also use the information differently. So if this was a cohort study, they'd establish that everyone's disease negative, which we already know that in 2017 at least they were. They'd establish their exposure status and then follow them and determine how many people got the disease. So it came to the same, it's basically, this is like the same slide as before. So something you'll notice is that the disease negative column is completely enumerated. Everyone who didn't have the disease is present, and I'll show you how that's not the case with a case control usually, where what a case control observes is it starts in 2020 basically, and what they do is they take everyone who is disease positive at that point and set them aside. We're keeping them all, and then among the people that are disease negative, we take a random sample. And then basically now we have 8 disease positive and 8 disease negative. 1-to-1 is a common case control structure. So now this is an incomplete enumeration of disease negative people, but it's kind of like they're missing at random in the sense that they were randomly selected in a way that the ratio of exposed to unexposed here is hopefully similar to what it was here, because we've selected using a method that is unrelated to their exposure status. And the reason that we would not use them all, basically, is that sometimes having more controls per case, like pretty much anything more than 4 controls per case, starts to level off the statistical efficiency, and there's no point in having more than that. And also, we might be taking really expensive measures on people, and using the fewest number possible might be cost effective as well as efficient for time and whatnot. So yeah, this is an incomplete enumeration, and you basically figure out people's exposure status by asking about some etiologically relevant time. You might be asking whether you were exposed in 2017, or depending on the exposure last year or last week might be relevant, but basically you're asking about their exposure status in the past. So both exposure and disease have happened, because when we had this group that we got together, their exposure and disease status is already present. The reason they're turning from like black to yellow is because we're figuring out that they have the disease. They didn't get the disease necessarily in 2020, but basically this is us determining that they have it, and then us sampling and us asking about their exposure status. And we come up with a table that ideally should come to the same conclusion as the cohort study, but with fewer people. So people generally consider cohort studies more valid and a better source of causal inference, basically. Part of that is true, and part of that is because basically case control studies are kind of misunderstood. But here are some reasons why we might think a cohort study is more valid than a case control. There's less of a potential for selection bias. So selection bias is basically when your study population and the population as a whole are different in ways, basically they have a different distribution with respect to the exposure and the outcome. So another way of saying that is those that end up a part of the study are a part of the study for reasons not only related to the outcome, but also related to the exposure. And it can end up with a distorted relationship between the exposure and outcome that is different than the population at large. And cohort studies are resistant to that because we select people based on exposure, and the outcome hasn't happened yet. So there's no real opportunity for us to include a disproportionate number of people that are disease positive or negative, because everyone is disease negative, basically. It's almost impossible for their inclusion to be related to outcome status. Well, it is in the sense that everyone's disease negative, but yeah. So basically, because the outcome hasn't happened yet, it's very resistant to selection bias. Cohort studies also have less potential for recall bias, because what recall bias is when the disease has occurred. Let's just say we have this group of people who have cancer and those who don't, and we're asking about exposure in the past. Those with cancer might recall their exposure status with greater vividness, basically, because they have cancer, they have spent more time recalling why they might have cancer and might have a more accurate representation of that. On the other hand, they might be looking for reasons they have cancer, might overestimate the things they've been exposed to, because it basically makes sense to them that they have been exposed to stuff because they know they have cancer. Again, because the outcome hasn't happened yet, and often exposure is being measured prospectively, there's not an opportunity for people to recall things incorrectly, or for people to recall things that are a function of their outcome status, because there might be some element of recall when you're establishing baseline exposure, but there's no chance for it to be influenced by outcome status because the outcome hasn't happened yet. Another thing to consider is that like a case control study can't always estimate the relative risk. The odds ratio is a measure of effect that has some intuitive meaning, but also at the same time, like a lot of people think a relative risk is significantly more interpretable. And there's only certain situations where case control can estimate a relative risk, only when the disease is really rare or when it is doing like an incidence density kind of thing. You can be more confident about temporality. And again, like a lot of these have to do with the fact that the outcome hasn't happened yet in a cohort study. So if the outcome hasn't happened yet and you witness them go from outcome negative to positive, you can be pretty sure that the exposure came first. And then like it helps you avoid reverse causality or situations where like exposure might have come after disease. And you're less certain of that in a case control situation. So why do a case control at all if there's these reasons that a cohort study is better? Well, it's more statistically efficient, and statistical efficiency is this idea that like statistical power is something you need to kind of understand a little bit in order to understand statistical efficiency, and I have a video on sample size calculations that cover that. But basically, when something is more statistically efficient than something else, it means that it is capable of detecting the answer with a fewer number of people, because the reason that we like to have large sample sizes is because it increases statistical power. It makes it like, even if there truly is a relationship between cigarettes and lung cancer, the smaller our sample size is, the less likely we are to detect that association, even though it really is there. So basically with a case control design, you can detect that relationship with fewer number of people. And the reason that is because cases, like people who are disease positive, are more information dense in the sense, like especially when a disease is rare. And the case control design seeks out people who are disease positive, and there's often the same number by design of disease positive and negative people. And that increases statistical efficiency greatly, where a cohort study and a case control study who are looking for the answer to the same question, the case control can do it faster and with fewer people. And it's not just statistically efficient, like I was saying just now. It's also just efficient cost-wise and time-wise. It's just efficient, period. It's good for rare diseases, where with a cohort study design, if the disease is really rare and everyone starts out disease negative, you might have to wait a really long time to accumulate enough disease positive people. You might have to wait several decades, and if you're doing like a master's thesis, that doesn't make sense. A case control design would make a lot more sense, where even though the disease is rare, you can purposefully seek out disease positive people, and because you're doing that without regard for exposure status, it can't be selection bias, because selection bias has to basically mean inclusion has to do with both exposure and the outcome. But we're selecting just on the outcome, getting all the disease positive people and a sample of the disease negative people, and we at no point considered exposure status. We did that after we assembled our group. So it's really good for rare diseases in that way. Also, when there's a really long induction period, and I'm just gonna go to the next slide because it talks about it. So this is like the path of disease, basically, where like your first contact with the exposure up until you've been exposed enough for it to cause disease. Like one X-ray, for example, isn't enough to cause cancer, but there's some sufficient number of X-rays that now cancer is possible. But once you reach that sufficient number of X-rays, you're probably not going to get cancer the next day. There's probably still some time for like the physiology of cancer to take place, until it is considered likely that it's been long enough since you've reached that sufficient number of X-rays that cancer can basically now be attributed to the x-rays. When this period is really long between reaching a sufficient number of, like, basically some event is triggered once you've had enough x-rays, all of a sudden, like, this like oncogenic process of this cascade that leads to your first cancer cell takes a while to develop. And basically disease status is irrelevant here, and you might end up having to wait a really long time between someone's exposure status and their diseasehood. And when that is a very long time, if with a prospective cohort study, you have to literally wait for that to take place. But for a case control study, basically you don't need to wait for that, because you're conducting the study when all of this has already occurred. And this is as simple as just flipping back further in the disease records of some hospital, rather than having to actually wait, because you have information on decades and decades at your disposal when you're doing it retrospectively.